Welcome to RLD Academy. This is lecture number 4 on operational amplifier. In this video, I am going to discuss instrumentation amplifier. Now, first, we'll try to understand why a special kind of amplifier called instrumentation amplifier is required. Now, generally, we are using sensors to sense some practical phenomena, and to amplify that one, we need some amplifier. Now let us consider one such situation. So I'll consider one source. So this is a DC source used in a bridge network to excite a bridge network, right? And this one is a Wheatstone bridge, and here suppose I'll use one sensor, right? So this resistance is, so this is RA, RB, RC, and this sensor, suppose I am considering one thermistor, I'll call it RT, R sub T. So this output and this output, so this is suppose V1 and this is your V2. Okay, and we need to take the difference between these two, because initially what we'll consider that RA, RB, RC and RT in such a way there is no difference between these two output voltage, means this is in Brand's condition. So the source voltage is suppose Vs. Okay, now in Brand's condition, you know that this is the requirement Ra upon Rt, it should be Rb upon Rc. In that case, the V1 is equals to V2. So there is no difference between these two end potential. Now, whenever this sensor will send some different temperature, the thermistor will send some different temperature, so its resistance value will vary, and depending on that you will find some higher value or lower value at the V1. So the difference between V2 and V1 you will get, but that difference is very small. So generally this V2 minus V1, this difference is very small, in range of millivolt or microvolt. Okay, so that millivolt or microvolt range voltage we need to amplify. So you see, if I consider, so this is your time for certain instant, this is the voltage level V2, right? And if I consider here this Rs equals to 0 for time being, okay, there is no source resistance, and now if due to this thermistor the change in temperature, you will get defined voltage level V1. So V1 and V2 are different, and suppose we are getting this thing, this is your V1 level. Okay, so this much is the difference between these two. That difference voltage we will call it Vd. So this difference voltage Vd, that is your V2 minus V1, and I've said that it is in range of millivolt, very small amount, we need to amplify it. Okay, however you see these V1 V2 values are not around 0 level, so it is having something here. So this is the middle value. So if I consider this middle value, so this is called common voltage Vc, and the Vc is middle one, means V1 plus V2 by 2. Okay, So we are not interested to amplify this common voltage Vc. We want just to amplify the difference voltage Vd. Okay. So what is the requirement? The requirement is this, that need to amplify Vd. Okay, because it is range of millivolt range, it should be amplified by some range in terms of volt range. Okay, and next one is that we want to suppress or eliminate the Vc component. Okay, want to reject, we'll call it reject Vc. Okay, so means in the output there should not be any component of Vc. Okay, Vc should not be amplified, it should be rejected rather. And this bridge circuit, so whenever you use this, you'll use one amplifier followed by this one. So what you will do, so obviously you are going to use certain amplifier here. This is one amplifier. Then you will get certain output voltage V0. Okay, but this amplifier should not disturb the bridge circuit. So bridge circuit should not be disturbed. Okay, by this the amplifier. Okay, so these are three important criteria for this application whenever you use one sensor. So to satisfy these first two, that we need to amplify only the difference voltage, and we wish to reject the common voltage Vc, we can use one difference amplifier. Okay, and that thing we have discussed in the last class. Okay, so again I will use this difference amplifier, but that difference amplifier may not be suitable for this case. And one thing is that, because third one, the bridge circuit should not be disturbed. Its meaning is that the amplifier should have infinite input impedance. Ri should be infinite. So here also this Ri should be infinite. Okay, so if the input impedance of the amplifier is infinite impedance, then the preceding circuit, the bridge circuit, is not disturbed. There is no loading effect on the preceding circuit. Okay, so here the requirement is that Ri should be infinity for this amplifier. So how to ensure this true? Okay, so for that special kind of filter is used, that is called instrumentation amplifier. So we can use one difference amplifier, but we have to make sure that input impedance of this difference amplifier is infinite. And one general op amp in open loop condition, it is having this feature. However, its gain is infinite. Thus, it cannot be used for this purpose because we need some finite gain, not infinite gain. Okay, so let us then consider instrumentation amplifier. Okay, so what we'll do first, we'll consider difference amplifier. Okay, and you know that in difference amplifier, the circuit is this one. This is one op amp. This is negative terminal. There should be negative feedback. Okay, and here in positive terminal, we'll give it this way. So this resistance is R1, this is R2, so RF, feedback resistance, this was R2, and it is R3, right? Now, in this figure, it can behave as a difference amplifier means this output voltage. So if this is suppose V1 prime, and I'll call it is V2 prime, then this output voltage will be simply some constant times V2 prime minus V1 prime, but with one condition. The condition is that if the ratio, this one, Rf upon R1 equals to this R3 upon R2, if it is maintained, then V0 will be simply Rf upon R1, this is the gain factor, multiplied by V2 prime minus V1 prime, right? Now you see here, in this case, what is the input impedance? So it is suitable for this one, that okay, it will reject the common mode voltage and it will amplify only the difference voltage. So this is difference voltage, right? So we can connect the bridge output voltage from V1 to this V1 prime and V2 to V2 prime. Okay. However, you see, if you look at here, what is the input impedance? In the last class we have discussed, this Ri is simply R2 plus R3. Because there is no current here, this current through this circuit is 0. So full current will flow through R2 and R3 only. There is no branch here. So these two R2 and R3 are connected in series. So this resistance input impedance is R2 plus R3. So obviously it is finite. It is not infinite, not very large. It is less than infinity. Okay. Similarly here. So if you look from this side, what the input impedance? Ri. Ri is simply R1 only. That also we have discussed. And that is obviously less than infinity. Okay. So you are not getting infinite input impedance in this difference amplifier. So whenever you will connect a bridge circuit, that bridge circuit will be disturbed. So to avoid this one, we can use one buffer circuit. That also we have said in last class. So to isolate this bridge circuit and this difference amplifier, we need to use one buffer circuit. So okay, unity gain feedback circuit, we can employ it. Okay, now here we'll use one similar idea, but again better one. We'll use two amplifiers of amp for this purpose, to isolate this difference amplifier and this bridge circuit. Along with that one, we can also get certain gain. Okay, let us consider that figure. Okay, now I'll draw this one in different color. Suppose this is the op amp, and here two op amp we need to use. Okay, and this is negative, this is positive, this is positive, this is negative. Be careful. Okay, because I need always negative feedback. So here what I'll do, I'll connect these resistances. Okay, and the negative feedback is connected here, right? So this is the arrangement, and now I can use the bridge circuit. Right, the bridge circuit I can consider in this case. This is your T. Okay, so this is your source, this is your BS, right? And from this end we'll connect to this one, and this one is connected here. Okay, so this is your V1 and this is your V2. Okay, this is RA, RB, RC, and it is RT. Okay, and now these resistances we'll consider it is suppose R and it is your RG. G stands for gain. We can control the gain. Okay, and this is suppose again R resistances, right? And then we'll connect this two end. This end is here and this end is here. Now we'll try to analyze this one. So what I want to imply, this network will behave as a buffer circuit as well as it can amplify, right? Now we need to explain this one. So what is the input impedance looking from this side? So you see there is no current because no current can enter this side in phi terminal. So this Ri is infinite. Again, if you look from this side, what is the Ri? Ri is infinite. So as input impedance for the both amplifiers is infinite, then this circuit, B circuit, is not at all disturbed because of this connection. Okay, out of this circuit. So these two circuits are isolated. Okay, so whatever difference will be there here, V2 minus V1, that we can amplify it by this difference amplifier. Okay, now let us check these two potential, V1 prime and V2 prime. Okay, so this potential is same. So this is your V1 prime and this is your V2 prime. Okay, now let us consider this current. What is the current here? This current is I, suppose. Okay, now you can notice that this potential is V1, this potential is V1, so this potential will be also V1 because of negative feedback and virtually connected. Okay, so this potential I can consider V1, and this potential I can consider it is a V2, because again there is one negative feedback. So this circuit is having negative feedback this by this element R. So these two end virtually connected. So this potential is V2. So this potential is also V2. So what is the current I? This current I is obviously V1 minus V2 upon RG. Okay, and you know that there is no current through this side or no current through this line because no current can enter into the op amp. High input impedance. So whatever current is coming here, that is coming from this line. So throughout this line, you will get the same current, I. Okay, can I say this one? So this current is actually I. Okay, so now can I have the relation then? So what is the relation? What is the I? I write it here. So this I is simply V2, or we can write V1 minus V2 upon RG, and that is same as V1 prime minus V2 prime, because this is the potential here V1 prime, this is the potential V2 prime, and in between the total resistance is R plus RG plus R. Okay, because there is no current here, no current here. So this current from this potential to this potential will be same. Okay, so this value will be R plus RG plus again R. Okay, from here, so what you will get if you combine these two, then can I write that V2 prime, okay, I'll write first V2 prime minus V1 prime, so I can put negative sign here. Okay, this RG plus 2R equals to V2 minus V1, right? So from here we can write V2 prime minus V1 prime is, so this is y upon Rg. Sorry, I can write Rg plus 2R upon Rg times V2 minus V1. Okay, so this is basically 1 plus 2R upon Rg V2 minus V1. Now from this one, what is your output voltage? So therefore the output voltage V0 is Rf upon R1. If I consider the difference amplifier is perfectly balanced, means Rf by R1 equals to R3 by R2, it is maintained. The gain is Rf by R1 and it is V2 prime minus V1 prime. So this V2 prime minus V1 prime I can replace. So you will get Rf upon R1. So this is basically your Vd, the difference voltage. Okay, so this is your 1 plus 2R upon Rg times Vd. Okay, so we are getting on output V0 equals to Rf upon R1, 1 plus 2R upon Rg times V0. So this is your gain of this amplifier. So this is Vd, remember, sorry, this is your Vd, difference voltage. So only difference voltage is amplified, and where gain factor is Rf upon R1 times 1 plus 2R upon Rg. Okay, now you see we can maintain this ratio. So only varying this Rf by R1 is not possible to vary the gain factor, because earlier in difference amplifier to get different gain we have to vary Rf or R1, right? But again that time you have to vary R2 upon R3 because that condition should be maintained. So every time it is very difficult to adjust those four values. So in this case what we can do, we can use one IC where all the elements are R1, Rf, R2, R3 are made in IC form, and externally we can connect one Rg. So just varying Rg, we can vary the gain factor. Okay, so this gain can be varied using the Rg only. So we can vary this gain. Gain is this one IC. This is Rf upon R1. Okay, it is fine constant. But this factor 1 plus 2R upon Rg, so this one we can vary only, and that could be connected externally. So only by one parameter we can vary the gain, and we can maintain high input impedance. So preceding circuit is not disturbed. So all the purpose is solved. And this amplifier is called instrumentation amplifier. Right? So next class I'll discuss the CMRR, common mode rejection ratio. That is one important concept, because here we have said that we want to reject the common mode voltage. Okay, so in practical circuit, this R1, Rf and R2, R3, I have said that it should be perfectly matched, but it is very difficult to get exactly matched ratio, because Rf by R1 it should be equal to R3 by R2. If there is slight mismatch in these values, then you will get certain output. This is some common mode output voltage at the output end. So it is not rejected perfectly. Okay, so that thing will be discussed in detail, and I hope you have got the concept. Now I'll give you one homework, a simple homework problem. Now consider this circuit, this instrumentation amplifier circuit it is, and I have considered one network here, then I have connected here, similarly here it's connected, and this circuit is given to you. Now can you find the output voltage? Load also I have connected 6 ohm. So what is the final voltage V naught? I hope you will be able to find it out and post your answers in the comment section so that you have understood this concept. Okay, I hope you have enjoyed this video, and if you enjoyed this video you can subscribe my channel, and to subscribe my channel you can click the subscription button, but don't forget to press bell button because then only you will get immediate notification of my future videos. I hope you are going to subscribe my channel. If you have not yet subscribed it, I'll be uploading lots of videos in this channel, so please keep watching my videos. Thank you.